Testing, testing. My go? All right. Hi, my name is Matt Bremer. I'm with Object Computing on the account side. So welcome everybody to this Groovy Grails meetup here in June. Before I introduce Matthew, I've got a couple of things that I just want to run by. Upcoming events with Groovy Grails. 3 training events, all led by Jeff Brown, the Grails co-founder. First one is next week. There is an advanced development with Grails 3. Seats are still available. It's the 13th through the 15th. So if you're interested, please log in, check it out. You can go to our website, objectcomputing.com. The second one is at GreatConf US. That would be July 24th and 25th. There is a significant discount if you're actually attending GreatConf. It looks like a 40% discount. And then if you actually go to the OCI website, we're offering 20% discount for attendees. The last one is publishing REST services with Grails 3, and that is an online training on August 4th. And once again, that is taught by Jeff Brown. There is an early bird sign up, so be sure that you get it. Want to thank RGA for hosting us here this evening, so thank you so much. And with that, I'm going to turn it over to Matt, and I'm going to give a quick introduction. So Matthew Moss is a core member of the OCI Grails development team. He has experience in many web-rooted technologies and a long history of C++, and has worked on various projects, including Guitar Hero and Rock Band. Worked with Matt before on several projects. He does an absolutely outstanding job, so I'm interested to hear tonight. Thanks, Matt.
Thank you. Get this microphone clipped on. Okay, so the presentation tonight is going to talk about Grails 3 and Firebase. We're going to talk about a plugin that I've been working on to bring the, got it. Sorry about that. We're going to talk about a plugin that I've been working on to bring the Firebase Realtime Database and make it accessible to Grails 3. So a little bit about me. As Matt said, I'm part of the Grails team. I joined OCI about 3 years ago and have been doing Grails work there. And I've also been doing web development for a number of years with various technologies. I've been coding for over 20 years with a wide variety of things, from industrial, Internet of Things, to web development, to game development. I'm a husband recently and father. And one of my favorite things to do is play board games. So if any of you want to get a game of Star Wars Rebellion going on, just let me know. And working on some other hobbies as well. Beekeeping. I actually have a hive in my backyard. My wife's idea, but I'm enjoying it. Only got stung twice. So what are we going to talk about at this meeting? We're going to talk first about what is Firebase, what services does it provide. In particular, we want to look at the Firebase database. There's a lot of things we could do with Firebase. The first one that I'm looking at is the real-time database. And then we're going to get into the Grails plugin that I've been working on. The Grails plugin is still in an early stage, but the development's going well, and hopefully will be available very soon. We'll do question and answers. If you have a question while I'm talking about something at that moment, feel free to yell out, and I'll try and address it in the moment, but otherwise we'll take them at the end. So what is Firebase? Firebase, this company was founded in 2011 and acquired by Google a few years later. They're an application development platform geared primarily towards the web and towards mobile devices, although there's nothing that prevents you from making native desktop applications. They have a whole bunch of different services they provide that mix and match well. And their first and most notable product is this real-time NoSQL JSON document database. And that's, again, what we're going to be talking about here. Some of the services Firebase provides, as I said, cross-platform web development, mobile development, real-time database, authentication using multiple providers. So they provide a library where you can log in with username, password, or email password, but you can also log in with your Google account, you can log in with Facebook, you can log in with GitHub, Twitter, maybe other ones I can't remember right now. Several of them, very common authentication providers. Even you can, if you really need a custom situation, you can code that up as well and make it work with their authentication system. They provide storage and hosting services, so storage for secure uploads and downloads, hosting for static web assets. Indexing is to, I presume, make your application work well with the Google search. They provide a test lab for Android. And there's a whole bunch more. There's dynamic links, remote configuration, invitations, analytics, advertising. What is the real-time database? As per a quote from their page, store and sync data with our NoSQL cloud database. Data is synced across all clients in real time and remains available when your app goes offline. So the kind of data they're talking about is basically a JSON document. Key value store with string keys and Boolean, string, numeric values. It's synchronized in real time to all connected clients. So real time, they don't provide, depending upon your definition of real time, they don't provide hard, at least in any documentation I've seen, they don't provide any hard guarantees. So some people might call that near real time or pseudo real time. But it's pretty quick. Most updates will occur within milliseconds from one client synced over to any clients watching that particular chunk of data in the JSON document. You can provide indices for queries to improve performance. You can provide security rules that live in the database and that will can be tailored per user, be tailored for a particular chunk of your JSON document. It continues to work offline, so your client, when it decides to read or write to the database, it has a local cache. And then when the connection is restored, everything will be synced back up, so you don't lose data. Because the clients can connect directly, it is a serverless application. Now, by serverless, really meaning you don't have to set up the server. Of course, they have servers. But it is pretty amazing how much you can get done in a single-page JavaScript application, interact with the database in your client, and never touch a server. Of course, in this talk, we're talking about Grails 3, which is generally being run as a server, so you can do that as well. But you can get a lot done even without a server. They provide for automated daily backups, which go to a Google Cloud Storage bucket, gzipped, and profiling. So you can log certain kinds of activity and then have Firebase generate reports based on that activity. So repeat the question again. It's serverless in the sense that you don't have to provide the server, right? Obviously, they have some servers going on managing all these things. So, but the setup is, for a basic application, could be very trivial. And you can write a whole lot of applications making use of Firebase that are client, like the code you would write is client only. I'm not sure I understand the distinction you're making, but I would say yes. You can build serverless applications. So developing for the Firebase database, you have a number of options available to you. If you're doing web, you're typically doing JavaScript. Android, Java, iOS would be Objective-C and Swift. Admin is a library they provide in Java and JavaScript for kind of server side. They provide a REST API, and they have a whole bunch of libraries. I don't think they write them, but they recommend them, or at least they're provided links to these on their website at that URL. So Clojure, Dart, Go, Java, Perl, Python, Ruby. I think there's even a PHP one if you're into that. They provide APIs for Unity and C++. And you can, for the times you need it, you can edit the database manually. So on the left is the database for this current presentation, which is at the moment empty. But I can come in here and say demo and add a value. And now I've just added data to the database. Obviously, this is not how you want to normally do things, but it's great for testing, visualizing things that have changed while you're developing. Just get rid of that for now. So let's talk about the Grails 3 plugin. My goal with writing this plugin is to provide access to the real-time database from Grails 3 applications. And I'm building it on the Java admin library. Since it's a JSON document, it's a very good fit for manipulating it with a Groovy map, key value store. So I'd like to be able to read and write to it like a map of string to objects. The objects, the values that go in could be strings, numbers, Booleans, but why not another map or a user domain object, something along those lines. So we want to make sure that we can do that. And that instead of the typical Java callbacks, which are, you'll see when I'm going to show some of the Java code to do some of these things. The Java callbacks are going to be replaced with typical Groovy closures. Also, since a lot of this stuff is asynchronous, there is a Grails asynchronous event system that I would also like to add in as time goes on. So here's a brief example of code. There's a Firebase document, which is a bean provided by the plugin. It gets injected in wherever you put that line of code. And I'm going to access a path in the document. So that's kind of a map-like access, array access, but instead of a single string, it can be a path. And Firebase will break that down appropriately into multiple levels of your JSON document. Access the values, that's going to give me all the users at that point. And then I can write a value. Here's another path, system status, and set value to a map. Let me go ahead and run this real quick. Give me one moment, not running the server at the moment. But there on the right, while the server gets started up, it's the same basic code. I also have it return the user so you can see it's going to return a JSON response, which will be viewable in the browser. Okay, there's the first problem. So I'm not going to get deeply into security rules tonight. I just wanted to show that your rules live in the database. So if I go to the rules page, you can see this is kind of a global rule for security in the database. Read and nothing can be written. And I just proved that with my permission denied error here. So let me go ahead, set this to true. Now there's lots of other things you could do. And they actually warn you, oh, it's globally writable, don't do that. But you can still do it. There are a lot of things you can do with security to You can have different levels of security at different places in your document. But that's a whole nother realm I'm not going to get into tonight for time's sake. Did you have a question?
My question was probably this part. You're not going to get into it. But it's at a high level. How would you, I'm assuming you could specify, like, the users have permission to write the database? What are the kind of rules that you're talking about?
Right. You can, if your users have a kind of ID, you can use that to check that they have access to certain parts of it.
Is it role-based, or is it?
I think you can implement a kind of role base, I believe, but there's a number of things you can do, and I can't say that I've gotten deeply into that section yet, but
Just for purposes of understanding what Firebase Document is that where if you did have like a certain user, you wanted to use that user or to write the Firebase document, is that something you have to configure ahead of time, or is that something you can ask at the right time?
right. Sorry about that. Yeah. So the question is, can the rules be configured at? Do the rules have to be configured ahead of time, or can they be modified on the fly? Is that correct?
Not to be modified, but used, right?
Used.
You have permission denied right now. If you were to do that, what you're saying, Firebase document key dot value equals.
I can do something. Do a comparison, for example,
Okay.
and this is something I've actually used to and tested and works, and that that value I'm checking against auth.uid right now is coming from my application's configuration file.
Is it being set in a header?
For this right now, it's being set in the Grails application YAML config file. For a client, you'd have to do something a little different, and that I can't get into right now, but. Correct. It's a schemaless. Correct. It's a JSON document, and you can. I don't know exactly how the rules fit in, as far as can you change that during runtime or something along those lines. But the database itself is just, think of it like a JSON document. It can be nested deeply. It can, for the most part, have anything JSON could have in it. Okay. So the server is running. Let me go back to, this demo link you're gonna see on this page and several pages is just connecting to the Grails 3 server to a controller action, call into the service to, appropriately named slide function. So here we're gonna get all the users from that path, Grails blog users. We're gonna write a value to system status. And we have some data in here at the moment. Let's just collapse some of this here. And it's going to return all users. You're going to see this in the browser once I connect. So you can keep an eye on, for a moment, the bottom of the Firebase console, because you're going to see those values change when I set the value, the system status value. There we go. So the console flashed yellow, meaning it was a value change. Those values changed. All the users were returned. And it's, as far as it's a Grails controller action returning JSON, and I have a plugin that makes that pretty in the browser so you can see what's going on there. So that's, you know, the very basics of reading and writing to a Firebase database from Grails 3. So there we go. Okay, not really. There's more. So before I get deeply into the Grails plugin side of things, I just want to show you some of the things that the Firebase database can do. We're going to look at it from kind of with Java code, some of their sample code, and we're going to look at connection authorization, data reading, writing, doing it asynchronously, querying data. We're not going to look at security and rules tonight, but there are options for that. And this documentation, it's pretty well documented online. So this is the code to connect to Firebase. There's a account credentials file, which you can read, some authorization information, authorization override information specifically. And then you pass these things into a options builder, set the database URL, build it, initialize your app, and then you can get a database reference at the end that gets you to the root of the JSON document. Credentials file looks something like that. This is a bit of JavaScript code. Didn't need it exactly this way in Java, but it just shows you the kind of data that's there without showing you my keys. The credentials are generated by Firebase. So you go to the web page for your application, you click on a link, it says, take this and paste it into your code base. Those are your credentials. If you are with a Google Cloud App Engine application, you can eliminate the credentials. You can just say, use my application engine's credentials, and it will just work. You can also eliminate the database auth variable override, that line that says optional. Most of the time, if you're dealing with a client, web, mobile, something like that, you have to authorize the user, you have to send the credentials to Firebase. That's how the clients will be credentialed. But for the admin, if you do not provide an auth override, it has full access. If you provide an auth override, authority override, then you can limit the admin library's access like it were a regular user. And that's why earlier I cannot not connect. I got a permission denied exception, didn't write something because writing was set to false, and I had an auth override. For testing, for development, you might want to just leave the auth override out. Your admin library has full access. Data is stored as JSON objects. Everything is JSON. Key value store, all keys must be strings. Supports the basic types of JSON, string, number, Boolean. JSON supports arrays. Firebase does not, per se. It does by having numeric indices in a map. And it has some smarts about it, so if you set a value and you provide an array, it's going to generate a map with indices 0, 1, 2, 3, 4, etc. And if you read something from Firebase that has indices 0, 1, 2, 3, 4, etc., or keys, I should say, not indices, numeric keys like that, it'll kind of recognize, okay, this is probably an array, and return it to you as an array. On the other hand, if you generate something with numeric keys, and then you remove a bunch of them, so now you have 0, 7, 33, it might start thinking it's no longer an array and send you back a map. So it's something to be aware of. I personally don't like the idea of using lists in here. There are other means to do a sequence of things we'll get to, but it's available. It's one difference between Firebase and JSON. JSON supports arrays, Firebase doesn't. Complex structured types, so whether it's a map or an object with class, these things work because it's a JSON documents, key value store, breaks down your object or multi-level maps and stores them away. Reading data in Java is with asynchronous callbacks. So you create a value event listener. You attach it with the add value event listener call to a database reference. So in this case, we're looking at, on the second line, system status. So we're going to, at the bottom, add a listener to that. So anytime the value changes at that node in your JSON document, system status, you will get this on data change callback, and it's going to get the value, get the message, and then print that out. And then later on, when we're no longer wanting to listen to that node, we can remove event listener. Very typical kind of listener pattern. Right, so the snapshot value, get value is, sorry, the question is the message a property of the node? So snapshot.get value is getting the value of that JSON node. And that may include, if it's a simple type, you're just going to get that simple type back. If it's a string, you get a string. If it's a number, you get a number. If you have more nesting in your JSON document, then you're going to get back a map. And so in this case, at system status is, I've been writing this all. So here's system status here. It's got author, message, and severity. So get value, whoops. Get value from that snapshot will be a map. And we want, in this particular case, the message in that map. What if you only need to read it once? Well, I mean, you have to create a listener, add it, get your value, remove it. They have a convenience function for that, add the listener for single value event. This basically does the same as the previous slide. You can watch for child events. So child added, child removed, child changed, child moved. Works similar to the other one. You're going to get a database reference. In this case, I want to look at the Grails blog posts. Post is added. So I add an onChild added to that node. It gives me back a snapshot. I get the value. I can read that value and provide a class, in this case, post class. So post is some Java class. It's going to fill in the members of that Java class, as long as they match up with the keys of the JSON document at that point. And then I can use the post just as I would normally. Excuse me. Of course, being a Java class, I've got to override a whole bunch of things. You'll see that it's a little simpler later on. Writing data works similar in reverse. I get a reference. I can access a child path. So here, the second line says get reference from the database. But if you're getting a subpath from an existing database reference, you use child. It works the same way. It's just accessing a subpath of your document. So at J Brown full name, I set value to Jeff Brown. At Z Klein full name, I set value to Zachary Klein. Very simple, straightforward. I can do multiple values at once in a single operation. And I can use objects. So here we have a user class. I'm going to create a couple users, put them into a map, set that value. Notice I'm setting value on a ref that is higher level up. It's at the users rather than the specific path of users, J Brown, full name, things like that. Now, one thing to keep in mind is this kind of code where I do set value replaces the value at that node. So if I already had some users in the database and I use this code it's going to wipe them out. Whatever existed there, there's a new value now. It's just Jeff Brown, Zachary Klein. That may be what you want. You may want something a little different. You have to be, as it's schemaless, and you need to be aware of what you're doing. You need your application to be controlling that kind of thing, or your client. The ID in this case, the question is, sorry, what was the question again? Oh, okay, so the question, is there a where clause kind of thing? No, there's not in that sense. Your where clause is kind of just setting providing the proper keys and paths. Now there is a means to update specific values without eliminating other values. That would be the update children call. So now I can provide updates to specific paths and specific, sub-documents of other documents, things like that. And I am doing an update children on the users node, Grails blog users. If there are other users, they will not be affected in this case. Putting in J Brown nickname, Z Klein nickname. So a lot of the time you're going to use this instead of set because this will not disturb things around it.
I'm not, maybe you already said this, but I'm not quite sure if you got one more slide.
Up?
Up, I'm sorry, yeah. So, is the admin library, is it going to be converting that user class into a JSON object?
So the question is, will the user class here be converted into a JSON object? Yes, I mean, it's I'm sorry?
The user instance, yeah.
Yes, it will be converted.
Okay. You'll get JSON object with string full name, string nickname.
Right, now in this case, right, so you'll have in your document J Brown, full name, Jeff Brown, full name, Zachary Klein. You won't have nickname in there because I never set it. It's currently null. Right now, you have to be careful about that because it is kind of writing null, but at the moment it's obliterating nothing. I don't have any nicknames in the database at the moment.
You have a nickname.
I believe it would overwrite it. Nope, the user class doesn't need anything extra. I think I'm still figuring out a little bit about what I think the way that Firebase is dealing with getting data into what they need to write to the database is to serialize it. No. There is some things, and this will be more when the Grails plugin is more fully fleshed out and complete. Users of the plugin won't need to see this. But for example, now if I have a domain class user and I want to write that, I have to ask for the user instance's properties. Because otherwise it gets some of those things that Grails attaches on behind the scene, and it doesn't like those and confuses it. So, but for the most part, the class that you see there, public class user, that's sufficient for Firebase to get it out to the database as a JSON document. You can use hash maps as well. And in fact, right, the screen you're looking at includes a hash map. I don't believe you need to override hash key. It may prove useful in certain situations, but I have not needed to do that. Now, before I said that Firebase can interpret sequences, raise lists, and convert that into a JSON document with numeric keys. And if it sees When you're reading values from the database, if it sees numeric keys, it will try and convert that back to a list. It has some smarts about it, but you can do things to confuse it. A better option would be to generate unique keys. And Firebase provides a way of doing that that is fast and can be used offline because it's client-side generated. And there's this push function. So I can create a, if I want to add a post to the database, I can say postref push. Then that gives me a database reference to a path that includes this generated key. I don't even know what the key is at the moment, but it's there. So now I can say, at that reference, new post reference, set its value to this new post. Jeff Brown wrote a document called announcing APL for Grails. With get key function, if for some reason I need that. And I can chain the calls together. So Zachary Klein wrote, Grails is awesome, I mean it. And it's just postref is the parent. I push new node, new key, set its value, done. And Firebase takes care of the work of making sure that that key will not conflict with others once it's synchronized. I don't know, that's magic to me. I haven't looked into that part, but part of the neat thing is that the generated key is based on a timestamp. Now, I would not use the key like some people figured out how to decode the key to get the timestamp back. If you need a timestamp for your own purposes, you're better to add that into the database as well. But you'll see in a short bit, we're going to do some queries. You may want to get things in chronological order, and you can use the key for that if you're using these push keys or your own keys. Transactions are available with Firebase. Yes, it's a key. The new post ID retrieved with get key is a key in a JSON document, the one that was just generated by push. Right, and that you can get that with that key. You can get that document. It's actually handed to you when you call push. You're getting back that subdocument. Now, it has no value when you call push. All it has is the key, but you can immediately set the value. Right, but that exists at the moment you call push. I would not use the key for a timestamp. If you need a timestamp, put it in yourself. People figured out how to use the key, but it's not a good idea. Transactions are available also. So if you have certain kinds of code that may have multiple users hitting it at the same time, that may be a good candidate for having a transaction. So in this case, there is a path at the top there to a particular blog post. And the particular blog post is that string that starts with -JRHTH. That's an example of a generated key. You don't really need to know what's in there, but that's an example. So for this particular post, we're going to get a subdocument called upvotes. I know, having written this code, that upvotes is an integer. So if I want to get the current value, like a user on a client hits the upvote button, I'm going to get the current value, I'm going to add it 1, set it back. If multiple people do that at the same time, they're all going to get the current value of, say, 1, and they're all going to set it to 2, when it really should be 8. So a transaction, you can group, just like any other database, you can group certain operations together, and they will go all at once or none at all. In fact, do transaction may be called multiple times. So you could start your work, and then Firebase decides, well, somebody got in before you. So it calls you again, and you have to start over. So these things should be small, they should be quick, they should be simple. And they should not rely too much on outer data or on some sort of state that will now be wrong the next if it has to call it multiple times. But you can do transactions. Some people want to use transactions to generate keys. Bad idea. If you have your own source for unique keys, you can use that, or you can use push is a better idea because push is fast, it's optimized, it's local to the client. Transactions always require at least one round trip to the server, if not more. So they're going to be slow, and they can't work offline. Push can. But if you need transactions, they're available. So what does offline mean? Offline means there is a local cache on the client. And so the client can continue reading from the database and continue writing to the database. And once the connection is restored, Firebase will sync that all up. Now, of course, if you're offline, you're not getting new messages, for instance, until you're synced up. But it won't just simply shut down. So we looked at some writing. I don't know exactly how the local cache works, but it does. So set value, in this case, and some of the other previous slides I showed, just takes a value. I'm going to set the value at this node in the JSON document. But what if I want to do it asynchronously? Well, you can add a completion listener. Very typical asynchronous Java kind of thing. Works with set value, works with update children. If you're doing a transaction, it has its own completion handler. You don't need it for push. Querying data. So a database reference is also the beginning of a query, because you're going to query a node, a JSON subdocument. So from this node, perhaps it's children. So they have different orderings. I can order by child or by child key in particular. So if I, for example, show you the posts database as it is now, you can see a bunch of keys. These are generated keys with author values and that's not the wrong one. Sorry, not posts, users. All right, so users, we have some keys. We have full name, we have post count. So I can order by the post count. It's going to order ascending. And then I can add an event listener to that query. And on child added, I will get back the information. And it's going to come back in order that I asked for. I can order by the key. This is where those chronological keys come in. Right? I can create timestamps in my data for my own purposes, but things into your database by pushing, you already have an easy way to get the ordering chronologically. I can order by priority. Now, you haven't seen priority yet. When you set a value, you can set a priority on that node of your JSON document at the same time. So it can be a custom ordering scheme that you can enforce using this priority field. And I can order by the value of the node. So if I've got some simple nodes that are just, the weight of certain objects or things in the database, then I can sort by that value. When you do ordering, as part of the security rules, you can add indices. They're not required, but they can help performance. You might want to measure that performance penalty you're hitting, but if you add an indice to a slow query, then you can help your performance there. You can limit your queries, returning only so many records. Limit to first, limit to last. All right, this can be good for if you've got a bunch of records and you want to only show 20 per page, limit to the first 20. Then cut your query down, limit to the next 20, and so forth. Or if you're ordering by, in this case, this example post count, I want to find the user who posted the least, or the top 10 users who posted the most. I can order by the post count, and I can, for the least, I can get the first one. Or for the top 10 posters, I can get the last 10. It needs an ordering. So I believe if you do not specify the ordering, it orders by key, which for this kind of query is not going to help you, but I mean, for querying like post count. You'll usually want to specify an ordering anyway. I can also do range of values. So start at, end at, and equal to. It's kind of like greater than, less than, equals. So if I want to find any users who posted only once, order by child post count equal to 1. Or I can find all the users who posted between 10 and 100 times. And I can combine all these. So order by child post count, start at 10, end at 20, or end at 100, limit to the first 20. So the 20 least posting users who posted at least 10 and not more than 100. It's a weird query, but it works. If you have more complex queries than that, you can, because usually, if we look at the example I had up here, once you've done a query, you can add a listener to that and get your values. In that onChildAdded or onValueChanged handler, whatever your handler is that you're using, you can start doing more queries. So this is not as flexible as, say, a typical SQL query language. But you can chain some of these together to generally accomplish what you need. All right. Let's now talk a bit about the Grails 3 plugin, because that was all Java code. And we're going to look at some corresponding Grails code and how that was made to work. I wanted it to be more of a groovy kind of API, like API, so you can use brackets to access your path and assign values and get values out of it. I want to support objects too. Not create all these manual event listeners. Just here's a onChildAdded, here's a closure. Call that one, I get a new child. Configuration is everything. So I don't need all that initial setup code that we had with Java. That's taken care of in the plugin. All you need is your application YAML to specify your database name, your credentials, and your authorization override. Authorization override, again, is if you're using the admin library. If you want to run as admin, you don't need that. If you're using the Google Cloud App Engine and you want to use its credentials, you get rid of the credentials block. So it's pretty simple configuration setup. And these values are just, when you go to the Firebase console, it just says, here's your values. You just plop them into your configuration file. All right. This is, so first line, Firebase Document. That is a bean that's, you're going to see that in most of these slides. It's a bean that's provided by the plugin injected where you add that line of code. So I can get a subdocument at system status. And then on that subdocument, if the value changes, then I'm going to get a snapshot. In this case, as a map. I'm going to access that snapshot's value and get the message and print it out. And then later, we'll shut that off. So let's go ahead and to system. And we are going to, I have the server running back here. We have two actions, start and stop, just so I can, basically the same code. Status.on value event changed. When I stop, it'll be value event changed off, or status.off. So we'll start this here. And you can see We already have a system status. Don't panic. That's what you see on the left. So one thing to keep in mind with Firebase Database is when you have a value changed or child added event that you're going to listen to, if that stuff already exists in the database, you're going to get those events immediately. So the value didn't change yet, but it gives you the starting point. All right? Or if I had been listening to child added, it would give me, like, say, on the environment there on the left, if I'd listened for child added on environment, I'd get back the first one and then the second one, even though I am not changing anything just yet, because it always gives you the initial information. So this is something to keep in mind when you're designing your database structure. You know, if you've got 1,000 things in a node, you may not want to start up your app and say child added on this node, because you're going to get all of them right up front. Now that may be fine if you started with nothing and you're just continuously running, but you want to keep that kind of thing in mind when you're designing the structure of this database. So I can come over to the, if you watch the, is that pretty readable? Okay. If you watch on the right, I'm going to come over to the left, change the value here, and as soon as I change it there, you see system status prints out, don't do Java. Now I'm only printing out message, but I'm watching system status, which is a higher level. So I can change the severity, and you'll see it prints out don't do Java again, because the node that I'm watching changed, even though I'm only accessing, printing out a different different value. So that's another thing to keep in mind. Know what you're watching, and know that when you load things, if you load things too high up in your structure, you're going to load that entire subdocument. So Google emphasizes being aware of your structure, flattening things, even replicating data if needed to keep things too deeply nested. Because if you have to get a certain value, then you have to get everything below it. Change the value once more. Now if I come back to the demo and I stop it, okay, that's just called another service call. This one here that does the off. All right, I'm providing a name up here on the that enables the listener, and one below that matches to disable the same listener. So now we can see we're stopped listening for status updates. So if I come back here and I say, everyone loves Groovy. Okay, the database did change, but I got no further notifications about it in the server because I disabled the listener. Pretty reasonable stuff. Okay. That's pretty simple code. A lot less than what the Java version provides, or forces you to write, I should say. Yes?
Sorry, quick question about that. What is status updates, that string you have?
So the question is, what is that second string in the on and off function status updates? That's just an identifier for my purposes.
Okay.
So that's the key. Whatever I pass into the on, that's how I remove it in the off. There may be, I'm exploring other ways to do that as well, but it's currently the way it is. Child events also work. So I can look at Grails blog posts, add a child added event, and get those values back, load them into a structure. So the posts is, let's go back to here. All right, there's a whole bunch of posts in the database already, and we'll go ahead and get them. Oh, the server code looks like that. I mean, basically the same thing. There's a little differences here or there between the server code and what's my slides just for presentation purposes. So all we did was we went and we asked for the child event added, got all those events. I think actually, what did I do? Oh, yeah, I did a little differently. Instead of printing them out, I added them all to an array, which then I returned to the browser client through the normal Grails 3 mechanisms. So that's why it looks like that. Oh, and that was, again, that was what I wanted to show. Let's do that here. Right, so this is a child added event I was listening to, and I got all the child without, coming over to the left side here and adding a new one. Like I said, when you do value changed or a child added, things like that, you will get back existing data initially. Gives you a starting point. That's something to be aware of. Need to read a value once, get value async. Right, because we're dealing with asynchronous processes here. It's going to return a promise. So I call value async. I can go off and do some other things. And then I can call get on that promise to get the values out of it. And that get call will block until the asynchronous value read comes back. Or it'll throw if there was an error. Now, a lot of the times, one of the main points of the Firebase database is that you're going to get responses in milliseconds. You may not have time to do anything else, or you may not want to do anything else while that value comes back. So you can do it synchronously too, and that's what the basic the get value call is. So this is where it begins to look a lot more like a simple map. So I can go to system status. I can get the message from there and get its value. I can get the severity from there and get its value. I can assert that they're the types that I expected them to be. I can provide a type. So I have a user class, and I can get a value at some subdocument, and it will come back as that class. If you need a collection, you have to do a little bit more fun for Firebase to understand what you want. So they provide this generic type indicator. I'm going to be looking to see if I can eliminate some of that in the plugin so you don't see as much of that, but you can do that as well. So here we have that code. It's basically the same. And we're going to print out some environment variables, and we're going to return that all through the normal Grails controller action means. Okay, let's run this demo. Okay, so it came back. The status it got from system status, the environment it got from system environment. It returned the MOS user, and no exceptions were thrown. And you can see I'm actually using, a real class here. That's all it is. In fact, this is a domain class. One workaround I have right now is that when you're accessing domain classes, you need to, it's more for writing than reading, but you need to, oh yeah, here, deal with just its properties. Hopefully that, I can eliminate that a little bit later.
When you do that, when you use .properties, it's still only storing those fields you've defined in the domain class?
So the question is,
properties will include a bunch of kind of metadata about the domain object too.
Right, so the question is, when you use .properties, is it only using the ones defined in the class and not the metadata? And I would say, yes, that's the way it appears right now. That's something is on my to-do list to investigate a little bit further, because I would like to not have to say dot properties at all. Writing data. At this point, you probably already know how to do it. So you can set value at a path. You can do a set value with a JSON document instead of simple types. So that second thing, users.doc.value equals, and it has a map with J Brown and Z Klein as keys. And they each have maps, so that's going to build out this JSON document. Now, again, as before, this is set value on the user's doc. So any other users that are there will get wiped out. I'm going to show you in a second. We have update as well. You can do a set value with a user class. And you can do it asynchronously and get a callback when it's done. This demo, this is slightly different because I didn't want to wipe out all my users, so I don't have the one that wipes them out. But the rest of it is there. There's an example of writing a user class. I needed to specifically grab just the properties because there was some metadata that was trying to be written out that Firebase didn't particularly care for. So if I run this demo, we're going to, right now in users, okay, we don't have Jeff Brown, we don't have Zachary Klein, we don't have Yvonne. So we're going to go ahead and run this. And if you watch the left side, when I click the link, you'll see them pop up. There we go. And this is making round trips to the server. This is not, there is a local cache, so you probably, if I had a client app locally, you'd see it even quicker. But this is doing a round trip, so it's very fast to get this stuff done. And there's the updates. So I can provide a map that will update only specific things. I would like to add something where you can provide objects, let's say only update this field or something along those lines. So I wouldn't have to, you know, I could just deal the objects and say only write these fields rather than build a new map with the values and paths and such. But this does work. So again, if we watch the left side, you'll see some nicknames added to Jeff Brown and Zachary Klein, and the post count for Sergio will go from 37 to 104. Boom. That was this code right here, basically the same. We can also do a more Grailsy way of pushing. So I can do the push call, and then I can do set value. Again, the same way as you do set value before, I can get its key if I need it for some reason. I added left shift operator. It does push and set in one quick move. So server code is basically the same as the demo. And we'll go ahead and run it. And you should see, let's see, this is posts we're going to look at. So go back to posts. You should see 3 new posts added. Probably all at the bottom since keys are timestamp based. So there we go, 3 new ones at the bottom. Announcing APL for Grails. Grails is awesome. I mean it. Anybody want a peanut? If you, like before, have things that require, say, read, modify, write, or doing multiple things that have to be done together, we will have transactions. I don't have that one working at just the moment, but it will look something basically like that. And this is basically the code you had on the Java slide that had all sorts more as before, transactions can run. So that closure, you don't want to, you want to be careful of sharing data with other threads that might be running in your Grails app. And know that this could be called, simultaneously by multiple users, depending upon how they access it. So that's why the transaction will possibly run it more than once. Since we're looking at trying to make a map-like API, I added a couple other things. There is a standard remove value in the Java API. So if I have a database reference, I can say remove value. It'll remove that value. I can also set the value to null. It's the same operation. The Groovy map adds a .remove function. I can just provide the key. It's going to remove the value at that key. Right. So notice that remove value works at a different level than remove. So .remove will remove a child based on the key I give it. Remove value will remove the value at the node that you're currently at. And you may want to get all the keys at a certain node. So there's key set. Now key set calls get value, which could be very inefficient if you have a large subdocument, because when you call get value, it has to get the whole subtree. So Google has, some pages on how to structure your data efficiently, and that can involve replicating data so as to have shorter paths, less nesting. There's a trade-off, because if you're replicating data, now you may need transactions to accurately modify multiple locations. But these options are there. Querying data. I threw together a little DSL just to seem like an interesting way to query your data. It does basically the same thing as before. So at a certain node, I can start a query, order by child post count, start at 10, end at 100, limit to 3, get each value. Now, the get value here is, remember that's returning a JSON document. We're looking at users here in this case. Let's go back to users. So value is going to be the value at the user's node, which is a map. The keys being G. Rocher, I. Lopez, J. Brown, J. Klee, M. Moss, right? And then they each have their value, which is another submap. So that underscore, because I don't care about the key in this case, I just want the user data here. Go ahead and run this demo. That's the wrong one. Oops. This one. So it's basically the same code, yes. So we're going to print it out here. Let's just clear that. And we'll go ahead and run that. Okay. And you can see it printed out in the IntelliJ console. Now, the interesting thing to note, it's printing it out in the order I asked it, because that callback, this callback here is, actually, sorry, it's the value is the get value is where it's getting the data, is coming back in the order specified, so order by child post count. That may not be the correct order here, because as a map in a Grails action, maps aren't guaranteed to preserve the order. So don't take this ordering on the right here at the moment as the order by key or the order by posts. But there's the top 3 posters. Now you notice that Sergio over here, he's got 104 posts. Why didn't he show up as one of the top posters? Well, Come on here. It's because my top poster is actually limited to 100. He had more than 100, so I didn't want him. I mean, he's a nice guy and all, don't get me wrong, but that's why he didn't show up in my query. And the second one, the 10 most recent posts, again, this is assuming we're adding things via push that generates these timestamp-based keys. And so I do an order by key. Actually, that should be the documentation where I was wrong there. I'm ordering by key and limiting to the first 5. So that's the 5 oldest posts. Sorry about that. All right, so we're probably quite over time. Phone's dead. I want to do one last demo here. We're going to look at a simple chat room-like application. All right, so which is contained basically in this function start chat. So I'm going to watch on, I'm going to have a root of path of chat in my database. I'm going to watch for new users on a subpath. When a new user is added, I'm going to get its value, and I'm going to store it. I have a map up here. I'm just keeping it in. And then I'm going to send a message. And I'm going to push value to a new path messages with a timestamp message that says welcome such and such person to the chat, and says this message was written by the admin, and I gave him a color white just to distinguish when you see the clients. And then I'm going to watch on another path sent. These are messages that were sent from the clients. And when I get a new incoming message, I'm going to get some of its details, the post key, the user key, the message itself, get some color that I've kept elsewhere in that map up above. I'm going to censor some bad words, guilty, fuchsia, sausage. All right, so in the message that came in from the client, if I find those words, I'm going to replace those words with a bunch of asterisks. This is where you could do other things in your server. You could take these incoming and store them in as domain objects in your database. You could collect statistics. You could censor things. You could do some AI to learn who to block and who to let through automatically. Any sort of typical, anything you might think of. In here, I'm just going to guilty stupid words. And then I'm going to send messages back out to the messages. So the messages subpath is the outgoing. That's what the clients will receive. And the sent path is the incoming from the clients. So the modified message will get sent out with the timestamp, the modified message, and the user key we already know, and we have their color, we send that back out. And I don't want the incoming to stick around. If I have to restart the server or something, or I don't need that extra data. So the incoming key, right, the message that was sent by the client, I'm going to remove it. Get rid of it. Now this should probably be in a transaction with the previous call. Make sure they happen at the same time. Like I said, I don't have transactions quite working yet, but you'd want to do something along those lines. So now we are going to come back to the demo here. And let's close up those. Where's my presentation? Let's have this a second. It's around here somewhere. Oop. What the heck? Oh, here's. Okay. So I'm going to start the server. Okay, you're not really seeing anything going on because the server is just listening for events. Nothing's happened yet, and there's no existing data in the database. I'm going to start a client. I'm going to run the node server that runs the client. There we go. Okay, so you can see this. These are some very weird clients we have. I'm going to go ahead and start another one as well. They have weird names and they have weird conversations. I'm not one to judge, but you can see that each time I created a window, the admin sent a message, says welcome such and such a person to the chat, and then they start sending their chat messages. You know, I can just scroll through this. Here's an example of one of the exciting something chicken. There's probably fuchsia chicken. Nobody likes fuchsia chicken. So you can see that our messages are coming in. If you look on the left, right, you see the messages when they come in under sent are in red. Red means they're deleted. So why, when they're added, does it look like they're deleted? Well, because the server immediately sees it, right, adds a new message to the end of messages, that's the one in green there, and immediately deletes the old one. So almost as soon as it comes in to the sent, the server removes it because it's added the outgoing to messages. And let's just get a little crazy here. Add some more chatters. And I really don't know, you know, what conversation they're having. This is all coded. Those timestamps are coming from the server. The word censoring, I think they're being a little bit more careful right now. Oh, no, there we go. That's coming from the server. And again, everything actually on their screens, like I'm not taking the client and giving them back their own information immediately. They don't get to see it until the server sends it back to them. Okay. This is happening extremely quickly. They do have profiling tools with Firebase that can help you identify pain points. All right, you guys are annoying. All right, finally, what's next? Some continued development of the plugin, fleshing it all out, making it more groovy, making it more Grailsy, making it more async, or providing new ways to interact with it asynchronously. There's a possibility to separate this into a Groovy extension and a Grails 3 plugin. Because some of the stuff that's going on, the Grails 3 plugin right now is mostly a new API that works like a map. Well, can we just provide that outside of a Grails 3 plugin, make it available to more users? So that's something I'll be looking into. What about Gorm for Firebase? All right, we have Gorm for a number of things. One of them is Neo4j. There's MongoDB is a JSON-like document database, key value store. Gorm for Mongo, why not Gorm for Firebase? Yep, that's it. So I'm open to any additional questions you have, and want to thank RGA for sponsoring the place and Object Computing for sponsoring me. And my information is there, my Twitter handle and my GitHub account. The repository for the plugin is not up and available yet, but I'm hoping to get it up and available soon. And OCI and myself will, make it known when it is available. So I can take any questions you all have at this point. No questions? All right, then thank you very much for coming to my talk, and hope you liked it. Have a good evening.